Okay, start recording. Today we're going to do statistic 1. Okay, so statistic 1 now is 9709/5. This is paper 5 for 2020 syllabus. Okay, before 2020, 2019 and before is not 5, it's actually paper 6. The paper will be 1 hour 15 minutes. Okay, and it cover 50 marks of the paper. Okay, so 50 marks for the entire paper, and it cover 20% of your entire A-level grade. Okay, so the topics that we have for the statistic 1, they are representation of data, okay, permutation and combination, probability, discrete random variable, and normal distribution. For your information, as one topic, they are all interrelated. Okay, you cannot say that I learn one topic, okay, I master one topic only. Okay, so the topic that can actually interrelated. So information from chapter 1 maybe goes to chapter 4. Information from normal distribution maybe go back to chapter 3 later. So they are all interrelated. So therefore, S1 is a topic that require you to actually understand combinations of topics. Okay. Well, for topic 1 wise, okay, it's actually especially for students who are actually not familiar with managing data. Okay, you have actually more things that you need to know. For topic 1, is representation of data. Okay, split it into 10 sections. Okay, there are terminology. Okay, measure of central tendency. Okay, and measure of dispersion. Okay, skewness, outliers, linear coding. Okay, stem and leaf, box plot, histogram, and cumulative frequency curve. Okay, put it this way, chapter 1 is how to manage data and summarize data. Okay, so therefore when you want to summarize data or how do you manage the data, you need to know what the data is about. Okay, you need to know what kind of data are you managing. So therefore whatever that you have here is how to manage and how to summarize. Okay, so first of all, let's look at terminology. Data means information. Okay, for example, a person's height, the weight, the eye color, the hair color. Okay, so maybe like favorite food, the income of the person, they are all information. So all of these information, they are data of a person. Okay, there are different category of data. Okay, at university level, we categorize the data into nominal, ordinal, and scale. Okay, nominal, ordinal, and scale. But in your A-level S1, we are not categorize it this way. Okay, this is just for introductions to the students. Okay, so in okay, so over here you can see, okay, so their data type can be put it as a categorical or numerical value. Okay, categorical can be ordinal, can be nominal, can be interval or ratio. Okay, ordinal means, okay, it can be given in the form of order. Okay, in the form of grade A, grade B, grade C, grade D. There's an order. Okay, nominal can be in the form of color. Okay, numerical, there will be a value. Okay, there is an interval of value. Okay, 0 mark to 100 marks for maths score. Okay, and so on. Okay, for your syllabus, we focus on ordinal data and scale data. Okay, how to actually categorize ordinal data and scale data? So ordinal data, you have a order. Okay, you have order as I say. So if let's say in the scale of 1 to 10, okay, 1 to 10, so maybe you clearly say 1 is the smallest, okay, 10 is the highest, or maybe you use a scale data, it's a scale data where you actually capture the value by using a certain tool. For example, a person weight. Okay, the weight, we have to use the weight to actually measure it, then only you know what is the value. The person's height, you need to use the ruler, okay, or measuring tape in order to measure, then only you can get the value. Okay, then over here we have we can also categorize the data into qualitative data and quantitative data. Okay, over here I write data and variable. Okay, data and variable. As I said earlier, data means information. Then variable is the subject that we studying. Subject that we investigating. Okay, if let's say I'm investigating height of a person, then maybe 178 cm. Okay, height of a person. So height is the variable. Okay, 178 cm is the data. And the data that we calculated, that we collected, it can be also split in the form of discrete and continuous. Okay, discrete means it's a whole number. Continuous means you have a decimal value. For example, the value on the die. So on the die, you have a 1, 2, 3, 4, 5, 6. So on the die itself, you don't see any value 1.1 or 1.5 or 2.01. Okay, you don't have those number. So the value on the die is called discrete data. Okay, and continuous data, they will may have a decimal place, for example, height. Although they 178 cm, okay, you can be 178.1, 178.2, 177.9. Okay, so you have a decimal value that will be continuous data. Okay, so for your syllabus, you are required to know how to record data. So we can record it in the form of ungrouped data or group data. Ungrouped data, that means we didn't categorize them. Okay, for example, math score from a group of students. Okay, 7, 6, 7, 5, 6, 5, 6, 8, 5, 7, 8, 9. Okay, so out of 10 marks, okay, out of 10 marks of the students, so students score 7 marks, 6 marks, 7 marks, and so on. Okay, or it can be written in the group data form. Over here, there are 4 examples of the group data. Okay, so maybe the first one, okay, number of family with such number of students. Okay, so there are 12 families that with no kids at home. Okay, there are 21 family with only 1 kids at home in the family. Okay, then maybe there are 8 families that with 2 kids at home. So 0, 1, 2, 3, 4, 5. Okay, there are number of children. Okay, so we can actually group it this way. Okay, of course, this one is actually a discrete data. Okay, so we can also group them in the form of interval, like a dash using this. Okay, so age in years. Okay, there are 6 person with age 15 years old to 19 years old. There are 7 person with 20 years old to 24 years old. Okay, there are 15 person with 25 years old to 29 years old. Over here, you will see that 15 to 19, then 19, after that the second row, you start with 20. There's this one we call it with gap. With gap, you can see the 19 and the 20 here with gap. Okay, so at the moment, okay, you are expected to know how to read the data first. Okay, so you may be wonder, okay, since I say here with gap, what about is there any example without gap? The next table, let's say salary. Salary is written in the form of the inequality. Okay, so annual salary, there are 7 person that actually earn 0 to 10,000. There are 82 people that actually earn 10,000 to 15,000. Okay, but this one you can see that no gap. Okay, no gap. Okay, or maybe light bulb. Okay, light bulb, the lifetime of light bulb. Okay, there are 3 light bulbs that actually last for 20 to 22 hours. Okay, there are 12 light bulbs that actually lasts for 22 to 24 hours. This one also no gap. Okay. So with gap or without gap, it depends on the subject that we investigating. Okay. So although that this one talking about time, this also talking about time, okay, but the number of hours is actually a continuous, the duration, but age we actually usually count it in distinctly. So as long as you haven't passed your birthday, we still call it the age before. Okay, only when you pass your birthday, then we will only categorize you on the next group. Okay, therefore you can see here this one with gap. So at the moment, you may be find that oh, it's so troublesome to actually recognize with gap, without gap, and so on. Okay, yes, in your syllabus, you do need to recognize them because the formula that you will be using to summarize, okay, back to the top, how to summarize the data will be different. Okay, it will be different. Therefore, you are expected to know how to actually uh, get the value, okay, by you referring to the different type of information. Okay, so next we are going to talk about measure of central tendency and measure of dispersion. Okay, measure of central tendency means where, location. Okay, let's say we have a max score of the two class, comparing two class. Okay, class A you have 82 marks. Okay, class B we have the 79 marks averagely. Okay, 82 marks average for the class A, 79 marks for the class B. So where it actually tell you the give you an idea about the class A averagely score higher. Okay, then the class B averagely score lower. So it actually tell you where. That's measure of central tendency. Measure of dispersion means spreadness. Okay, spreadness. Whether is it concentrated or is it widely spread. Okay, so although that class A maybe score 82 marks higher score, but maybe there are a few of them that actually score too high. So maybe 3 of the students actually score 100 marks, 100 marks, 100 marks, 100, 100, 100. Okay, of course this 3% will actually help to pull up the marks, the average score. Okay, but instead the lowest marks of the students may be like only 50. Okay, then compared to the second class students, okay, uh the everybody is score about 85 marks to 75 marks. Okay, so there is nobody that actually score extremely high or extremely low. Okay, extremely high or extremely low is actually very concentrate. Okay, so then under these circumstances we say that the spreadness, this one is more spread, this one is less spread. So we can see the spreadness by using the diagram here. Okay, so if let's say for a diagram, okay, we usually can use a mu to representing the central tendency and the width here to representing the spreadness. So if let's say we compare the first diagram, we can actually see that okay, which one this is the number line, which one is higher, which one is lower. Okay, or the second type, we can actually see that which one is more concentrated, which one is more spread. Okay, so this will be the first two things that we want to summarize when we're dealing with data. Okay, location and spreadness. Okay, in the real world, we actually use the concept of location and spreadness a lot. Okay, especially for example in sport. For example, Lee Jong-wei playing badminton. We talk about it as accuracy and precision. Okay, so uh, okay, let's say this is throwing a dart. Okay, throwing a dart, you have a target board. Okay, so you can see that, okay, high precision, high accuracy. So high accuracy means you hit the target correct location. Okay, high precision means very concentrate. Okay, concentrate. So this one you can see that, okay, highly concentrate, okay, with the correct location. This one is highly concentrate, but it's actually always off target. Okay, always off target. Maybe because of the person, the hand, how he actually throw it. Okay, so he just need to adjust the location of the hand. Okay, you also can have, okay, high accuracy, low precision. Okay, all the throw are almost in the target. Okay, all the throws are almost near the target, but okay, it's still not very concentrate. Okay, it's still a bit wide spread. Okay, or they can also low precision and low accuracy. Okay, so we can actually do this in terms of sport. We also can use the words precision and accuracy in business. Okay, when we talking about risk here means spreadness, spread. Okay, so the widely spread, the higher the risk. The lower the spread, okay, the more concentrate, the lesser the risk. Okay, of course, in business, we also talking about human factor as well. Okay, whether a person, an investor, whether is high risk, whether can accept high risk, high return. Okay, low risk, low return, high risk, low return. Okay, of course, nobody actually go for high risk, low return, or maybe low risk, high return, which is definitely ideal. Okay. So next one, okay, we're talking about how to categorize or actually summarize the data. Okay, there will be few things that you need to know. Okay, about how to manage the data. Okay, over here, up here, you will see we have the information about ungrouped data and group data. Okay, and we will have the type of summary that you have. Okay, so let me zoom out a little bit, then you actually can see that there are quite a number of items that you are expected to know. Okay, let's say you can actually, okay, crop this actually crop this page, okay, and save it on your screensaver or something. Okay, so that you actually know, these are everything that you need to summarize when you are given the data. What are the things that you need to know? You need to know about mode, you need to know about mean. Okay, you need to know about median, you need to know about range, you need to know about lower quartile, Q1, you need to know about upper quartile, Q3, you need to know about interquartile range, you maybe need to know about percentile. Okay, you need to know about variance, formal definition. Okay, you need to know variance, simplified formula, and you need to know standard deviation. Okay, so you also have, okay, although that you have everything here, okay, you also need to know the different way to do it when you're dealing with ungrouped data or group data. So you need to know what to do. Okay, so we're going to do it one by one by using the data that we have up there. Okay, so let's say I have this data here. Control C. Okay, I scroll all the way down. Okay, let me adjust some size. Okay. Okay, so this is the data that we have. Okay, first of all, I'm going to rearrange them from small to big. Okay, so I will have a 5, 5, 6, 6, 7, 7, 7, 8, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, from here you will see mode equals to 7, which is the most numbers appear. Okay, then you have median. Okay, median is the value at the middle. So therefore you have 5 numbers here. You have 5 numbers here. The value at the middle is 7 plus 7 over 2, which is a 7. Okay, then you have the mean. Okay, they actually need you to have a sum of all the value divided by the number of data. Okay, so I sum all the number 5 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 8 plus 8 plus 9. So I have a 68 divided by 10, therefore you have a 6.8. Okay, so what are the things that I need? Okay, let's see, go back. Okay, after that I have range Q1, Q1, Q3, IQL. Okay, then after that I have range. Range is the highest number minus by the smallest number. So 9 minus 5. So I have a 4. So that will be a range. Then I have Q1. Okay, Q1 is the number that Q1, Q2, Q3, they are the numbers that actually separate the data into 4 equal parts. Okay, so I already used this red line to split the data into lower 5 and upper 5. Then from the lower 5, I split into half again. From the upper 5, I split into half again. You see that these 3 numbers will separate the data into 4 equal parts. That means 2 numbers each, 4 equal parts. 5, 5, 6, 7, 7, 7, and 8, 9. So your Q1 here is 6, the one for the first blue line, and your Q3 here is 8, the second blue line. Okay, so Q1, Q2, Q3 separate the data into 4 equal parts. Okay, then after that we have Q1, Q3, then we have IQR. IQR means Q3 minus Q1. Okay, you have 8 minus by 6, that actually give you value 2. Okay, after that, what do we need? Okay, we need percentile. Okay, percentile. Okay, percentile means the k over 100n position value when arranged in order. Okay, so in other words, okay, let's say P25. Let's say for P25. Okay, means 25 over 100 position. Okay, so you have 1 over 4 position. Okay, n position. Sorry, I forgot about the n. N position. So that means it's Q1. Okay. So of course, if the question want to ask, they may not ask about 25. Okay, they may ask about any other numbers percentile. Okay. So after that, we will have the variance. Okay, in the formal definition. The formal definition tells us that x minus by x squared over n. This is formal definition. Okay, so what exactly is this thing? Yeah. Okay, so I already have my mean value to be a 6.8. Okay, that means all the numbers here I can minus by 6.8. So I have 0.2, negative 0.8, 0.2, okay, or negative, oh, 6 minus 6.8, yeah, so 5 minus 6.8, you have a negative 1.8, then negative 0.8, then I have a 8 minus 6.8, you have a 1.2, then you have a 5, which is give you negative 1.8, okay, then 7 give you 0.2, 8 give you 1.2, and 9 give you 2.2. Okay, so over here I sum the number. Okay, that means I sum the number here into this, okay, and square them. So I have 0.2 square plus 0.8 square plus 0.2 square plus 1.8 square plus 0.8 square plus 1.2 square plus 1.8 square plus 0.2 square plus 1.2 square plus 2.2 square. So I have a 15.6 over 10. So I have 1.56 as my result. Okay, if this one, if I do it as a formal definition form. Okay, next, you also can have a simplified formula form. Sum of x squared over n minus bar x squared. Okay, so over here, the sum of x squared, that means I need to take this and sum all the number first. So it becomes 7 square plus 6 square plus 7 square all the way to 9 square. Okay, so let's see what is the number that I get. Okay, 7 square plus 6 square plus 7 square plus 5 square plus 6 square plus 8 square plus 5 square plus 7 square plus 8 square plus 9 square. So you have a 478 over 10 minus by the mean is 6.8, 6.8 square. So let's see what do we get, divided by 10 minus 6.8 square. So I have a 1.56. So you can see this and this, they are the same number. Of course, they have to be the same number. Okay. Then, okay. Of course, they must be the same number because they are the same thing. Okay. So it's just that this one is your formal formula. This one is your simplified formula. Okay. Don't be surprised during exam if the question give you in the form of formal formula. You will be expected to know what to do. Okay, you will be expected to know what to do. So for further math students wise, okay, further math students will need to know how to prove this into that. You need to know how to prove this into this. Okay, for further math students. Okay, then in the end, so we refer to standard deviation. Standard deviation is square root of variance. Okay, will be square root of 1.56. Okay, so you take square root of 1.56. Okay, then you will write in three significant figure, so it will be 1.25, 3 significant figure according to the exam standard. Okay, this will be the demonstration of the ungrouped data. Ungrouped data. Group data. Okay, stop recording. Start recording. Okay. Now we shall continue with group data. Earlier, what we did is ungrouped data. Now we need to deal with group data. Okay, for the group data here, I'm going to show you example for the with gap and without gap. Okay, I will start with the one without gap. Okay, without gap, no gap. Okay. So this one, the example with no gap. Okay, so let's see what are we going to do. Okay, number one, okay, we're going to deal with model class. Okay, model class means the group with the highest frequency. Okay, it's not that we cannot calculate the mode from the group data. It's just that it's not covered in your syllabus. Okay, it's not inside your syllabus. So the model class will be the group, the class with the highest frequency over here will be 40. Okay, equals to 40. Okay, so oh no, sorry, not equals to 40. So we can see this is the highest. Okay, the group is 24 to 26. So 24 to 26 like this. Okay, that will be our model class. After that, we will have our median. Okay, our median. In order to do our median, okay, we will need some information of the formula that are given above. Okay, I write it in the form of L plus N over 2 minus CF over F times by C. Okay, so first of all, before I actually deal with this median formula thing, okay, I create a column called cumulative frequency. So cumulative frequency from the first group I have 3, then after that 15, after that I have 55, after that I have 65, then I have 70. Okay, I have total data of 70. 70 divided by 2 means 35. 35 here means it lies within 24 to 26 because 35 is inside here. So L means the lower boundary of the medium class. So the medium class that we're identifying is 24. So the lower boundary of the medium class is 24. Then plus there will be 70 total frequency divided by 2 minus by cumulative frequency before that class. So since this is the medium class that we're referring, cumulative frequency before is 15. Okay, so I'm going to write 15 over here. Divided by frequency of the class. The medium class is this. The frequency of the class is 40. So I'm going to write 40 over here. Then times by class size. Class size is the lower boundary, upper boundary minus by lower boundary of the medium class. Therefore, over here, I have a 26 minus 24. Okay, so I press my calculator. Okay, 35 minus 15 divided by 14, okay, times by 2 plus by 24. So I have my median as 25 here. After that, I have my mean, okay, mean I will have sum of fx over sum of f. Okay, I will need my midpoint. Okay, midpoint x, so I have my midpoint, so I use another color, midpoint x. So midpoint, okay, 20 and 22, 20 plus 22 divided by 2, I have 21, so my midpoint is 21. So this one is 23, this is 25, this is 27, this is 29. Okay, happen to be they are all the nice number, so it's easy for me to do the calculation. And after that, okay, I have my 21 times 3, okay, plus 23 times 12, plus 25 times 40, plus 27 times 10, plus 29 times 5 divided by 70. Okay, let's see what we get. Okay. In 23, 25, 27, 29. Okay, frequency 3, 12, 40, 10, and 5. Okay, so this I will have my sum 1754 over 70. Then I have my mean of 25.057. Okay, That will be my mean. After that, I need my range. Okay, range is the highest minus by the smallest. The highest value is 30, the smallest value is 20. So 30 minus 20, therefore I have 10 here. Okay, that will be my range. Okay, after that, I will have my Q1. Okay, Q1 also using the interpolation formula. Okay, using formula. So I have a L plus 1 over 4n minus CF over F times by the C. Okay, so the total data is 70. So 70 here, 70 divided by 4, 70 divided by 4, I have a 17.5. So 17.5, where is it lies into? Okay, it's lies into 24 to 26 again. So the lower boundary of the Q1 class is 24, then plus by 70 over 4 minus by 15, the cumulative frequency before the class, divided by 40. Okay, times by the class size, so 26 minus 24. So I will get, let's see what is the number, 70 divided by 4 minus 15 divided by 40 times by 2 plus by 24. So I have a 24.125, okay, as my Q1. Then I need my Q3. Q3, again, L plus 3 over 4n minus CF over F times by C. Okay, so this time is 3/4 of the 70. So 70 times 3 divide 4, I will get a value 52.5. Where exactly is 52.5? Oh, it's fall under this group again. Okay, so 52.5. So I'm going to calculate, okay, by using the same class. Okay, 52.5. So I have 24 plus 3 over 4 of 70 minus 15 over 40 times by 26 to 24. Okay, so minus by 15 divided by 40 times by 2 plus by 24, I will have a 25.875. Okay, so from here, okay, so from here, I will get my interquartile range as Q3 minus Q1. That will give me 25.875 minus by 24.125. Let's see what we get. Minus by 24.125. Okay, I have a 1.75 as my answer for interquartile range. Okay, after that, I will have my the variance. Okay, so variance. Okay, so if let's say I use the formal formula, I will have sum of f x minus bar x squared over sum of f. Okay, the calculation is actually a bit messy. Okay, so I'm going to skip this part. I'm going to go straight to the how to say, the simplified formula. The simplified formula will be in this form: sum of fx squared divided by sum of f minus by bar x squared. Okay, so sum of fx squared, so if we do a similar calculation like this, sum of fx squared will give you 44166 over 70 minus by 1754 over 70, the whole thing square. Okay, then after that, you will have your variance as 3.08244898 for your calculation. And in the end, if let's say we deal with standard deviation, there will be square root of the variance, so 3.08244898. I will get my standard deviation as 1.75569. Okay, so this will be the example without gap. Okay, so next we're going to deal with example with gap. With gap. With gap. So this one with gap. So I'm going to use this. Okay, for the calculation. Control C. Control V. Okay, so this time the calculations with gap. With gap. Okay, and from here, okay, let's do the very first thing. That will be the model class. Model class. The group with the highest frequency, you can see 15 here. The highest frequency is 25 to 29. So that will be our model class. After that, I need to calculate my median. Okay, before I calculate my median, I need to know what is my total frequency first. So my total frequency, I will get 6 plus 7 plus 15 plus 6 plus 8 plus 3. So I total of 45 here. Okay, so 45 divided by 2, I will have a 22.5. I need cumulative frequency, so I write cumulative frequency here. 6, then 13, then 18, okay, then 24, then 32, sorry, not 18, 28, 28, then 34, okay. Did I calculate? 13, 28, 34. I think I sum it wrongly again. Cumulative frequency. Okay, I'll have a 6, okay, 13 and 28, 34, 42, 43, and 45. Okay, that will be my cumulative frequency. So for the median here, okay, so for 22.5, okay, 22.5 fall under this group, 25 to 29. Okay, 25 to 29. So this is within 25 to 29. Okay, so I will need to use lower boundary of that group. So 24.5, because this one with gap. You see there's a before 25, there's a 24 here, 24, 25. So we need to take the midpoint. So 24.5. So plus by 45 over 2 minus by frequency, cumulative frequency before the class will be 13 over 15 frequency of the class, then multiply by, okay, the class size of the group. So I will have 29.5 minus 24.5 here. So let's see what do I get. So 29.5 minus 24.5. Okay, I have a 5 here. So times by 42 over 2, then minus by 13. Okay, 11, then divided by 15, then plus by 24.5. So I have a 27 and 2 over 3. Okay, or 27.67. Yeah. Okay. So this will be my median. Then I have mean. Okay, for the mean, I will need my midpoint. So midpoint. So 15 plus 19 divided by 2, I have a 17. Okay, so 20 plus 24 divided by 2, I have a 22. Okay, So 25 plus 29 divided by 2, I have a 27. So 30 plus 34 divided by 2, I have a 32. Okay, 35 plus 39 divided by 2, I have a 37. Okay, 40 plus 44 divided by 2, I have a 42. And 45 plus 49 divided by 2, I have a 47. Okay, so for the mean, okay, I need to calculate the frequency times by the midpoint. Okay, so sum of them. So 17 and the 6 plus 22 and the 7 plus 27 with a 15 plus 32 with a 6 plus 37 with a 8 plus 42 with 1 plus 47 with 2, then divided by 45. Okay, so let's see what is the number that we can get. So this one, 17, 27, 32, 37, 42, 47. Then frequency of 6, 7, 15, 6, 8, 1, 2. Okay, and I will have the sum of 1285 over 45 that give you 28.56. Okay, that will be my value of mean. And over here, my range will be the highest minus by the smallest, so will be 49 minus by 15. Okay, that actually give you so 49 minus by 15, so I have a 34 here. After that, I need to calculate my Q1. Okay, Q1, 45 divided by 4, so it's 11.25. So you see there's a 13 here, so it's within 20 to 24. Okay, within 20 to 24. So my lower boundary of the class will be 19.5 plus 1 over 4 of 45 minus cumulative frequency before the class 6 over frequency of the class 7. Okay, and multiply by the class size of the group. So this will be 24.5 minus 19.5. Okay, so equals to, so minus 6 divided by 7 times by 5 plus by 19.5. So I will have a 23.25. Then my Q3, okay, 45, okay, times by 3 divided by 4, you have a value 33.75. 33.75 is within 30 to 34. So within 30 to 34. Okay, within 30 to 34 here. So are you referring to 30 to 34? Okay, I write down the formula. 30 to 29.5 plus 3 over 4 of 45 minus cumulative frequency before the class. Okay, 28 over frequency of the class, which is 6. Okay, then multiply by the class size. So 34.5 minus 29.5. So let's see what we get. Minus by 28 divided by 6 times by 5 plus by 29.5. So you have a 34.2917. Okay. Then I will have my IQR, Q3 minus Q1. So minus by 23.5. So I will have 11 point. Okay, maybe I just write out the number first. 34.2917 minus by 23.25 give you 11.04. Okay, so this will be my IQR. Okay, so in the end, I still need to calculate my variance. Okay, let's see what do I get for my variance. So variance, okay, I go straight to the simplified formula, which is sum of x squared. This is a group data. Sum of fx squared over sum of f minus by x squared. So I will do my calculation of sum of fx squared. I will get 39335 over 45 minus by this one 1285 over 45, the whole thing square. Okay, I will get a value of 58.69135802. Okay, standard deviation is the square root of the variance value, 58.69135802 square rooted. You have a 7.66102853. Okay, so what you see from here, they are all calculation of managing data. So you will see that when it comes to different type of data, we have a different way to do the calculation. Over here, you see three example of one ungrouped data. The second one, group data with no gap. The third one is the group data with gap. Okay, so trying to practice and identify all the formulas. Stop recording. Okay, start recording. Okay, earlier you already seen the calculations of summarizing data by using different calculation, by using different example. Okay, now comes to the theory part. Okay, from the above calculation, we use mode, median, mean to measure location of a distribution. Okay, mode, the median, and the mean are all three different ways to measure location to actually identify where is it. Okay, then we also use range, interquartile range, and standard deviation to measure about the spreadness of a distribution to see whether is it widely spread or is it narrow or concentrated. Okay, why do we need to learn so many different ways to actually calculate exactly the same thing, which is the location and the spreadness? Okay, so there will be theory involved. The theory is talking about when to use, how to use. Okay, so during exam, you will be maybe expected the questions appear to be so this data we calculated the mode, the median, and the mean. Which one is the best to describe for this situation, for this data that we collected? Okay, so you need to know how to actually write out the answer with the reason. Okay, so first of all, if it's ungrouped data or raw data, okay, so it provides you the exact means, the actual mean itself. While the group data organized into interval, okay, let's say you have 100 people in the hall, okay, you cannot identify, you cannot just count them, how many 1 mark, how many 2 marks, how many 3 marks. So usually we actually group them together. Okay, all the students from 1 mark to the 10 marks, okay, raise your hand. Count. 11 marks to 20 marks, raise your hand. So count. So you actually group them into interval. Therefore, what you get is an estimated mean. Okay, what you get is an estimated mean because you have in the group, you have no idea how many 1 marks, how many 2 marks, how many students with 3 marks, and so on. Okay, it can be less accurate due to assuming all values within the group are the midpoint. Okay, when we do the calculation of the average, we're using midpoint to do the calculation, isn't it? So therefore, okay, it's an estimated mean. Accuracy. The mean calculated from the ungrouped data is always more accurate than the mean calculated from the group data. Okay, group data provide a simplified overview of the data distribution, but it comes at the cost of some accuracy in calculating of the mean. Okay, it's just talking about the same thing. Next, you need to decide on the best measure to use in the particular situation. When do we use mode? This is used when the data are qualitative or when the quantitative is either a single mode or bimodal. Okay, there is no mode if all the values occur only once. Okay, if you have a qualitative data, for example, color, okay, best sales of the color of the car, okay, which color actually sell the most, you can actually see it by using the mode because it's the most highest frequency. Okay, then median, this is used for quantitative data. It's usually used when they are extreme values. Okay, as no, as they do not affect as much by affecting the mean. Okay, what it means here, the median will not be affected by the extreme values. Okay, so if there is an existence of extreme values, we can actually use median as our measure of location. Okay, another reason will be if the data is skewed. Okay, it means it only tends to one side. Okay, so third one, mean, this is used for quantitative data and use all the piece of data. It therefore gives us a true measure of the data. However, it's affected by the extreme values. Just like earlier I mentioned about the math score of the class A and class B. Okay, a class A, although their average is high, okay, but because it's being pulled up by a few students that actually score very high. Okay, so therefore they may be affected by the extreme values. Okay, here got more explanation. Advantages and the disadvantages. Mode, unlikely to be affected by extreme values. Useful to manufacture that need to know the most popular style or size, just like the car that I say. Okay, can be used for all set of qualitative data. Okay, disadvantage, ignore most value, rarely used in further calculation. Mean, take all values into account, frequently used in the further calculation. The most commonly understood average can be used to find the sum of the data values. Okay, this one everybody know. Cannot be found unless all the values are known. Okay, are likely to be affected by extreme values. So if you have no idea all the values, okay, we're just making assumptions. Median can be found without knowing all the values, relatively affected by the extreme values. Okay, the advantage, only take account of the order of the value, so ignore most of them. Okay, so if the questions appear to be asking advantages and disadvantages questions, so try to understand, try to write out the reason. Next, to talk about standard deviation. Okay, much simpler to calculate than IQR. Okay, advantages. Data value do not have to be in order. Easier to work with algebraically when doing more advanced work. Okay, and it take account of all the data values. So the advantages, far more affected by extreme values than IQR. So again, it's the same reason, affected by extreme value. Give greater emphasis on the last deviation than the small deviation. So when the data is actually big, okay, very widely spread, it's actually enlarge the thing of the value. Okay, to actually show to the students the relativity of widely spread or more concentrated. Okay, that will be the theory part. The next thing that we want to investigate is we want to investigate about the skewness of the data. Okay, there are three types of skew that we can actually say. We can say that is positively skewed. Okay, we can say that is symmetrical, or we can say that is negatively skewed. Okay, for syllabus, there are 5 ways to identify the skewness. Okay, there are 5 ways to identify the skewness. They are looking at the histogram or diagram. Number 2, calculate the mean, median, or mode. Number 3, looking at the diagram of the box plot. Number 4, calculate the Q1, Q2, Q3 value. Number 5, using the formula. Okay, so these are the set rules. Okay, these are the fixed rule. So as long as you see this type, then you have to know how to actually conclude the skewness. Okay, so the first one, this is the number line, okay, the highest peak is the mode. Okay, if you see the mode is on the left side, okay, the mean value, okay, then the long tail on the right, then we say it's a positively skewed. If the mean median mode value is about the same value, okay, we say it's symmetrical. If the highest peak mode is on the right side and this is a long tail on the left, then we say it's a negatively skewed. Okay. Second, you should able to see, okay, the value here is just corresponding to the diagram up there. Okay, so if mean is greater than median greater than mode, we call it positively skewed. Okay, if mean equals to median equals to mode, then we say it's symmetrical. If mean is lesser than median lesser than mode, then it's a negatively skewed. A lot of students complain about there are so many things here, how are we going to memorize them? Okay, the rule of thumb is you can actually use mean minus by median. Okay, if give you a positive value, then positive skew. If it give you a negative value, it can give you then is a negatively skew. If it give you a 0, then it is a symmetrical distribution. But this one is not an official rule. It's just something easier to help you understand. That's all. Okay. Then next, number 3. Okay, if I draw a box plot, okay, this is the bigger size of the box or on the right side. Okay, then we say it's positively skewed. If the is two boxes, they are the same size, then we say it's symmetrical. For negatively skewed, if it's the bigger box is on the left side, okay, then we say it's a negatively skewed. We also can see by you looking at the Q1, Q2, Q3 value. So you know that this is Q1, Q2, Q3. Okay, so Q3 minus Q2 of course is bigger than Q2 minus Q1. So you again here. Okay, this is Q1, Q2, Q3. So Q3 minus Q2 and the Q2 minus Q1 is if they are about the same, then it's symmetrical. And this is Q1, Q2, Q3. Okay, so Q3 minus Q2 is smaller than Q2 minus Q1, then it's a negatively skewed. Number 5, formulas. Okay, so sometimes during exam, they will actually give you the formulas for you to actually calculate the skewness. Okay, the formulas you are not required to memorize. Okay, if whatever they ask you to calculate, you just plug in the information in to do the calculation. How do you actually make your conclusion? If it's a positive, then you say it's a positive skew. If it's a negative, then you say it's a negatively skew. If give you 0, then you say that it's symmetrical. That's all. Okay, this is the part for the skewness. Stop recording. Okay, start recording. Okay, the next part that we're going to deal with is the outliers and extreme values. Okay, so just like what we have earlier, okay, other than it keep mentioning about the extreme values, isn't it? So if it's no extreme values, we can use mean. When there is extreme values, we need to use median. So over here, they will be important for us to identify whether a data has a extreme values or not. Okay, so we will need to calculate what we call the upper fence and the lower fence. The fence is actually a checkpoint, okay, to check whether the value is actually more than the is there any value outside of the fence or inside the fence. Okay, upper fence we will do it as a Q3 plus K times of IQR. Lower fence we do it as a Q1 minus K times of IQR. Okay, in the event that the question didn't mention about the K value, okay, then you will use 1.5. Okay. So if the question gives you the specific k value, you follow whatever the question is given. Okay. So let's look at some practice questions. Okay. Okay. So over here you can see I have the data over here. Okay, the data over here. So what I can do is, okay, I first identify Q1, Q2, and Q3. Okay, I've identified Q1, Q2, and Q3. Do I really need to? Okay, never mind. So I just identify Q1, Q2, Q and Q3. So first of all, let's see what are the numbers, how many numbers that I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 times 3, so 45. So 45 divided by 2, I have a 22.5. So I separate the data into 22 and 22. Okay, so 15, 16, 17, 18, 19, 20, 21, 22. Okay, so before this particular 28, there are 22 data here. After this 28, you also have 22 data over here. Therefore, this 28 is my Q2. You can take a moment to do the counting. Okay. After that, I have the bottom 22 numbers. Okay, 22 divided by 2, I got 11. So I count 11 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I split. Okay. If you maybe then we can actually count again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You will see that this number over here, okay, in between, separate the lower part into two equal parts with 11 numbers and 11 numbers. So this number over here, okay, is the midpoint between these two values, 23 and 23. So 23. Yeah. After that, we also need to calculate the upper part. So I need to calculate 11 numbers from the upper part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Split over here. So calculate again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have these three numbers will separate the whole data into 11 numbers, 11 numbers, 11 numbers, 11 numbers. Okay, so the third number that actually says separate the 11, okay, will be 34.5. Okay, then from here, my IQR is equals to, okay, 34.5 minus 23, I will have 11.5. Next, I want to calculate my upper fence and lower fence. Okay, the upper fence I will have 34.5, okay, plus 1.5 of 11.5. Okay, this one put it down. So I calculate the number. So times by 1.5 plus by 34.5. So I have a 51.75. Okay, then the lower I will have 23. Okay, so plus minus, so follow the formula here, minus 1.5 of 11.5. So 23 minus 1.5 of 11.5. So I'll have a 5.75. Okay, so how do we actually interpret this number? You will see that these numbers, or for these 45 numbers, okay, are all within 5.75 to 51.75, all within 5.75 to 51.75. Therefore, no outliers. Okay, the conclusion will be no outliers for this set of data. Okay. Okay, you can use this 5 set of data to actually help you to calculate all the calculations that you need. Okay, you actually can take it as to calculate mode, median, mean, okay, Q1, Q3, IQR, range, uh, then you have variance, standard deviation, or maybe is there any skewness? Okay, what is the skewness and what is the outliers? If there is any, you can use this data here to help you identify. Okay, so that will be the practice question. Next, we're going to go into linear coding and combine min. Okay, the concept of linear coding. So this one is a linear coding. Okay, linear coding says, okay, I have original x, okay, but I coded into some coded y. I find the summary of y. After that, I decode it back to get back the summary of x. So a lot of students say, what's the trouble? Why do we need to do this, do so troublesome about here? Why can't I do this straight away from the original data x? I got the summary of x, then good enough. This is due to historical event. Okay, when the first time that the first computer was actually invented, okay, the computer is actually as big as a room, and the processing speed is actually very slow. Okay, due to that, okay, mathematicians come up with the idea about why don't we change the data that we get into something nicer. Okay, so that it doesn't burden the computer. Okay, so once the computer help us to do the calculation, we can easily just decode it back. Okay, so we don't need to ask the computer to do so much work here. So this was the idea. Okay, and the syllabus is called linear coding. Okay, that means in the real world there are many different coding methods. Okay, there are many different coding methods. So it's just that the one that you're learning right now in your syllabus is called linear coding. What exactly is linear coding? The linear coding is in the form of, okay, y equals to a plus bx. Okay, right, little a plus bx. Okay, so the best is give you an idea about what is it. Okay, let me see. Okay, over here. Okay, I have the original data of 1, 2, 3, 4, 5. Okay, and I want to calculate this 3 coded data. So y coded into the form of x plus 10, z coded into the form of 2x, w coded into the form of 2x plus 10. Okay, let me calculate for the y first. So from the y, okay, I will have the data of 11, 12, 13, 14, 15. Then I will have the sum of the y value. Okay, sum of the y value 11 plus 12 plus 13 plus 14 plus 15 of 65 here. Then I have sum of y square value. Okay, sum of y square value of 11 square plus 12 square plus 13 square plus 14 square plus 15 square. Okay, I will have 855. Okay, then with this I can calculate by y. Okay, I have a 65 divided by 5. I have 13, and the variance of y, okay, all right, in the symbol form, variance of y will equals to 855 divided by 5, then minus by 13 square. I have a 2. Yeah, okay, so this is the information that I get. Okay, let's go for the second. Okay, I get the value data of z. Okay, z here. So z give us 2x. So I will have the data of 2, 4, 6, 8, 10. Okay, then I do the summation of z. Okay, I have 2 plus 4 plus 6 plus 8 plus 10. I have a value of 30. Then I have a summation of z square. So 2 square plus 4 square plus 6 square plus 8 square plus 10 square. I have a 220. And bar z here. Okay, I have a 30 divided by 5. 30 divided by 5. I have the value 6. And I have a variance of z equals to 220 divided by 5, then minus by 6 square. So I have the value 8. Okay, the third one, I get the value of w. Okay, the w says is coded into 2x plus 10. Okay, 2x plus 10. 2x plus 10, I can write out the new value. I have a value 12, 14, 16, 18, and 20. Then sum of w, okay, sum of w, I sum them up. 12 plus 14 plus 16 plus 18 plus 20, I have the value 80. Then sum of w square, 12 square plus 14 square plus 16 square plus 18 square plus 20 square. So I have a 1320. Okay, then I calculate sum of w, average of w, mean of w. 80 divided by 5, I have the value 16. And the variance of w, okay, says, okay, I have 1320 divided by 5 minus by 16 square. I have the value 8. Okay. Now we look at the original x itself. So original x, I have sum of x equals to 1 plus 2 plus 3 plus 4 plus 5. I have a 15. Sum of x square equals to, okay, so 1 plus 4 plus 9 plus 16 plus 25. I have a 55. And bar x, okay, equals to 15 divided by 5. I have a 3. And the variance of x equals to, okay, variance of x equals to, I have a 55 divided by 5, then minus by 3 square. I have the value 2. Okay, so what exactly that we're calculating here? So right now, we have the value of the summary for the x, the y, the z, and the w. For these sections, you need to learn about a few rules. You need to learn about if y equals to a plus bx, ax plus b, okay, ax plus b, ax plus b, then, okay, sum of y equals to a sum of x plus nb, bar y equals to a bar x plus b, variance of y equals to a square variance of x. These will be a few rules that you need to learn. Okay, let's verify them one by one. Let's verify them one by one. Okay, the first one. Okay, I say sum of y equals to a sum of x plus nb. So y equals to x plus 10. So you will see that this one, 65 here. Okay, 1 times of sum of x, 15, plus by 5 times of 10 equals to 15 plus 5 times of 10. 15 plus 5 times of 10. So you can see it matches with the formula. The second rule says the bar y equals to a bar x plus b. So this is x plus 10. So 13 equals to 3 plus 10. 3 plus 10. Okay. And the variance of y says, okay, variance of y equals to a square variance of x. A square variance of x. So I have a 1 square, because there's 1 in front here, 1. Okay, 1 square times by variance of 2. So it's a 2. So it's the same. Let's look at the second one. The z is 2x. 2x. The a is a 2. The b is a 0. So this one, you see that the t here is, follow this formula, is 2 times of 15. 2 times of 15. You see 2 times 15 plus 5 times 0. Okay, of course this is 0 over here. Then the 6, what is the 6? It says it's 2 times of the 3. 2 times of the 3. 2 times of the 3 here. And what about this 8? It says it's 2 square of the 2. Follow the formula. You have to see 2 square times by 2. Therefore, it gives you 8. And the last one, this 80. Okay, w is written in the form of, coded in the form of 2x plus 10. 2x plus 10. Therefore, the a is 2, the b is 10. Then follow the formula. You have 2 times of 15 plus 10, plus 5 times of 10. I write them nicely. Okay, equals to 2 times of 15 plus 5 times of 10. So 2 times of 15 plus 5 times of 10. Yeah. Then the w, let's see what is the w. The w, we have a, okay, bar w. So a times 3 plus 10. Okay, a, so 2 times of 15, or a 2 times of 3. So this is a 3 here, sorry. 3 plus by 10. So you can see 2 times of 3 plus by 10. Then what about the variance w? Okay, variance w, you can see that the 10 being ignored. Okay, there's no b here in the formula. So equals to the 2 square of the 2. Therefore, it's equals to 8. According to the design of the questions here, what does it mean? It means that during exam, they can give you the data, they may not give you the data. In the event that they're not giving you the data, you are expected to know the rules. You are expected to remember the rules. Okay, stop recording. Start recording. Okay, now we continue with the combined mean. Combined mean is talking about if we have the data with two set of data and we want to combine them together. So what can we do? Okay, so we combine the sum together. Okay, so over here for this example, the height x value, okay, of the 10 boys are summarized as this and this, and the y summarized as for 15 girls is summarized as this and this. Okay, so find the mean and standard deviation for all the 25 people. Okay, so therefore you need to combine sum of x. That will give you 1650 plus 2370. That actually give you 1650 plus 2370. Okay, give you 4020. And you need to have a combined sum of x squared to have a 275490 plus 377835. So 275490 plus 377835, you have 653325. Okay, then there will be a new mean. Okay, that actually give you 4020 divided by 25. 4020 divided by 25, you have a 160.8, and the new variance will have a 653325 over 25 minus by 160.8 squared. Okay, 653325 over 25 minus by 160.8 squared. So you have a 276.36. Hence, the standard deviation will be square root of this number, give you 16.62. Okay, so as your answer. So this is how we can actually do the combined mean. So you need to have a combined sum of x squared and a combined sum of x and combined sum of x squared. Okay, so over here, at the bottom, I write out the summary. Okay, so in the case of linear coding, so y equals to ax plus b, then the sum of y equals to a sum of x plus nb, bar y equals to a bar x plus b, and the variance of y equals to a squared variance of x. Okay, in the case of combined mean, you have two set of data with sum of x, sum of y, sum of x squared, sum of y squared. Then the new mean will be like this, and the new variance will be look like this. Okay. So over here, you will have some practice question that you can do. Do try it out. Okay. 7. Okay. We have the stem and leaf diagram. Okay. What we have a raw data. Okay. So we are required to rearrange them into the order. So there will be the stem. Okay. There will be the leaf. There will be the quantity, and you have the key. Okay, then you need to present all of these components. So don't forget that when you present them, you have to present them in the order. So on the leaf, you have to see is in increasing order. Okay, 5 7 7, then 2 2 2 3 4 7, like this. All you need to do is just arrange them in your data. Okay, you also can have example of a back-to-back stem and leaf. Okay, back-to-back stem and leaf. Back-to-back stem and leaf is to most of the time, the question appear to ask you to do a comparison of the data. Okay, so you have the year of 2016 here, you have the year of 2017 here. Okay, so to help you actually identify the value, so you will need to know how to arrange them properly. Usually you have the 3 marks. Okay, for the questions. Okay, so of course you will be expected to arrange them into the correct order. Okay. Okay, though for each of these presentation, okay, you need to know what is the advantages and disadvantages. Okay, so what will be the advantages and disadvantage that involve with this so-called stem and leaf. Okay, you first of all, you need to have a small amount. Okay, we can't really have a lot of data, so it's help us easily find Q1, Q2, Q3. Okay, and the back-to-back stem and leaf allow us to do a comparison between the two set of the data. For example, we can compare about the skewness, we can compare about the extreme values, okay, and so on and so forth. Okay, so that will be the theory part of it. Okay, so there will be some practice question that you can do. Okay, next we have box and visco. Okay, or what we call box plot. Okay, over here I've cropped from one real life example. Okay, so this is from the World Cup, from each team from each country. Okay, they actually show you about the age of the players. Okay, so you can see that there's a dot here that actually representing extreme values. Okay, there will be Q1, Q2, Q3. Okay, and in the range of the values, okay, that the youngest youngest player to the oldest player, and so on. Okay, so you can see that, okay, by as a comparison, you can see that Netherlands and England, okay, you have the players that lower than 20 years old, younger than 20 years old. Okay, this is some real life example when you do box plot, and you can, as you can see, box plot here can actually help us to do a comparison. Okay, so what will be the theory of it? Okay, it's actually compact data summary. Okay, it can help us to do easy comparison between the data. Okay, we can identify outliers, as for example, like the black dot here. Okay, we can easily tell the symmetry and the skewness. Okay, you can see the green color here, they are about the same, about symmetrical. But you can see the pink color one, this one is actually longer on this side. Okay, so that actually give you negative, this one is a positive skew. Okay, positive skew. So how to draw? Okay, so you have a box plot like this. Okay, then first of all you need to have a number line. Okay, so when they are required to draw on the paper, please remember that in your exam you will be not given additional paper, so you will only draw it on the answer sheet itself. Okay, if you draw anything wrong, there is no replacement, there will be no replacement. Okay, so you need to do it nicely. Okay, of course you draw it with the pencil. Okay, so with 2B or HB pencil, so it's clearly be seen. You need to have the number line, okay, that representing the scale. Okay, then you have the value of the Q1. Okay, Q1, you have a value of the Q2, the value of the Q3. Okay, you will have the outlier. Okay, if then you have the value, okay, the smallest value and the biggest value within the upper fence and the lower fence. Okay, within the upper fence and the lower fence. Okay, then over here, okay, this example is just to tell you how do you actually interchange between them, the data. Okay, the questions may actually give you the stem and leaf information. Then they might ask you to convert it into the stem and leaf. Okay, they may be asked you to convert it into the stem and leaf. Okay, so outlier here is after we calculate the upper bound and the lower bound. Sorry, upper fence and the lower fence. Okay, so you will see that the 5.5 here, the 5.5 is outside of the interval. Then therefore you have a 5.5 here, and this is a 5.1. Okay, the data, the largest data within the upper fence and the lower fence. Okay, so this is what it means. Okay, let's verify it by looking at the number. So I will need Q1, Q2, Q3, IQR, okay, lower fence, upper fence. Okay, let's try to identify the value. Okay, I have a 30 data here. So 30 divided by 2, I have 15. So I have a first 6, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I have a 3.8 here. Then after that, from the 15, I identify 7 and 7. 6, okay, 7. So this number 1, 2, 3, 4, 5, 6, 7. So this is a 2. So 3.2. Then I have Q3, 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. So you can see that the number 3.2, 3.8, and 4.0 separate the data into 4 equal parts of 7 number each. Okay, of 7 number each. So from the IQR here, so IQR, I have a Q3 minus Q1, 4.0 times minus by 3.2, you have a 0.8. And the lower fence here, you have a 3.2 minus by 1.5 of IQR. So let's do the calculation. 0.5 of 0.8. So I have a value 2. And upper fence here, I have a 4.0 plus 1.5 of 0.8. Let's calculate the number. Okay, I have a 5.2. Okay, you will see there the upper fence is 5.2. Okay, the 5.5 is outside of the fence, and the number, the data value within the fence is 5.1. Therefore, it's drawn in this way. Okay. Next, histogram. Okay. Please understand, for your syllabus, we are dealing with frequency density, not frequency. Okay. So therefore, from the past, if any of you learn it to do by using frequency, we are no longer doing that. Please remember. Okay. So therefore, how to actually get the draw the frequency the histogram by using frequency density. Okay, let's look at example. Okay, so I have a data. Okay, this one I have a 5 group. Okay, this is a group data: 25 to 30, 30 to 35, 35 to 40, 40 to 50, 50 to 80. Let me try to write the data. Rewrite the table. Okay, table is already here. So 25 to 30, 30 to 35, 35 to 50, 40 to 50, 50 to 80. And you have a frequency 55, 39, 68, 32, 6. So this two column is the information given by the table. Then I need to calculate class width. Okay, the class size. That means I take 30 minus by 25. Okay, I have a 5. Please understand, I use 30 minus by 25 because this is a no gap example. No gap example. If there is a gap example, I need to use something 0.5 and a 0.5 here to minus. Okay, so this is a no gap example. I use 30 minus by 25. So I have a 5, 5, 5, 10, and 30. Okay, then I calculate, I generate this column. And after that, I need frequency density. How do we do frequency density? So frequency density is frequency divided by class width. Okay, so you can see divided. So 55 divided by 5, you have 11. So it has to show you here. Okay. So in the end, I have 11, 7.8, 13.6, 3.2, and 0.2. You need to use this as your vertical axis. You need to use this part as your vertical axis. Okay, so in the end, we do the drawing. Okay, so over here, this is just an illustration. Of course, during exam, you'll be given the 2 cm type of graph paper. Okay, so you have the 25 to 30 here with the height of 11. So you can see frequency density 11. Okay, then you have the 30 to 35, you have the height of 7.8, and so on and so forth. Okay, then you can actually draw the frequency, the histogram here. Okay, then after that, okay, let's look at this example. You have a reverse question. Okay, reverse question. Okay. Okay, so over here, so how do we actually deal with, oh wait, not this question. Okay, over here. Okay, example 5, you have a reverse question. Okay, so in a shopping survey, a random sample of 104 teenagers were asked how many hours to the nearest hour they spent shopping in the last month. The results are summarized in the table below. Okay, let's move the table slightly to the left so we have more space to draw. Okay, a histogram was drawn and the group of 8 to 10 here was represented by the rectangle with the width of 1.5 cm, 1.5 cm, okay, and the height of 3 cm. Okay, there is something else that you need to learn, is something about proportional. Okay, so over here I will need my class width. Okay, I write in between here. So this one with gap. Okay, this one with gap. So I need to use something 0.5, 0.5 here. So a 5.5 and negative 0.5. So 5.5 minus negative 0.5. I have a value of 6. Okay, this will be 7.5 minus by 5.5. I have the class width of 2. Okay, so 10.5 minus by 7.5. I have class width of 3. Okay, and so on and so forth. Okay, so I need 16. Then better go down first. So 15.5 minus by 10.5. I have a 5. I have a 25.5 minus by 15.5. I have a 10. And I have 50.5 minus by 25.5. I have a 25 here. Okay, what you need to learn is, okay, class width will be directly proportional to width. Directly proportional. Okay, then next will be frequency density. Okay, frequency density. Frequency density. Okay, frequency density. So frequency density, I have a 20 divided by 6. 20 divided by 6. Okay, I have a 10.3. 10 over 3. So 16 divided by 2, I have a 8. So I have a 6 here. I have a 5 here. I have a 1.5 here. I have a 10 divided by 25. I have 0.4 here. And this frequency density will be directly proportional to height. Directly proportional. Okay. So this is the information given to us. Then they ask us calculate the width and the height of the rectangle represented by 16 to 25. 16 to 25 is this particular one. So they want asking for this number and this number. What will be the width and the height in cm for the bar? Okay. So first of all, we identify the directly proportional part. So you can see that 3 cm give 3 unit give you 1.5 cm. 3 unit give you 1.5 cm. Therefore, 10 units give you, okay, that divided by 2. So this one should be give you 5 cm. Okay, 5 cm width. Then the next one, directly proportional. 6 units give you 3 cm. So 1.5 units give you how many cm? So obviously divided by 2, so 0.75 cm. So our conclusion is the width of 16 to 25 bar equals to 5 cm. The height of 16 to 25 bar is 0.75 cm. Okay, this is actually what happened. So you need to know how to interpret the questions as well. Okay, so most of the time the question will be appear as a the interpretation of use of information. And finally, the last one is cumulative frequency curve. Please understand in your syllabus there is no polygon. No polygon. That means we are not drawing straight line. We are not drawing straight line. The red color is not supposed to be. You only have the curve, which is the blue curve here. Okay, so from here, okay, we're trying to generate the table. Okay, we're trying to generate the table. So this table we convert into this. Okay, sorry, wrong color. We convert into this. Okay, so then we are trying to identify the coordinates. Okay, so lesser than 1, so 0.5, this one with gap again, with gap. Okay, lesser than 0.5, there will be 0 left. Lesser than 2.5, you have 8. So this, you can see that this is a cumulative frequency. Okay, lesser than 4.5, you have a 28, so on and so forth. So from here, we generate a few coordinates. The coordinate of 0, 0. Okay. Oh, sorry, not 0, 0. 0.50. Okay, 2.58. 4.528. 7.566. 9.576. 11.5 and 80. After that, I use this coordinate and plot on the table. So therefore, you have this point here. Okay. Then we'll draw the curve. Make sure you connect the curve. After that, how do we actually use this? Okay. We can actually use this to actually answer a question. So maybe, okay, one of the application will be identify Q1, Q2, Q3. So that means other than using the formula method to identify Q1, Q2, Q3, the question can also ask you to use the cumulative frequency curve to identify Q1, Q2, Q3. Okay. Then, of course, depends on the questions. Okay. How do we actually read the graph to answer the questions accordingly? Okay, this one I will leave it to you to deal with the past year questions, because past year question you will see they can actually ask all kinds of different things here. Okay, then that's all for this S1. You can see that this S1 is actually cover a lot of things, because okay, because this part is actually the one of the hardest topic. Okay, the hardest topic in the sense that because you have a lot of things to actually consider. Okay, for those who doesn't like to memorize, okay, sorry for you. This one is more like a memorizing type of the questions. Okay, that's all for today. Thank you very much.